Alright, so as said in the description, this video is going to be a little different than the ones that we typically do. I'm going to try to keep my screen up as I talk through this one a little bit. And I'm going to try my best not to be completely repetitive of the video that we just gave, and just focus on the reactions that's taking place inside of the atomic bomb. Sorry about that. Let me back this up so we can get to kind of the screens I'm looking for here. So let's start with let's see if I can get this screen up. So this one right here, we're looking at the reaction inside of the bomb. I'm going to move my face over here. Hopefully you can see that all right. What we're looking at here in this context is the uranium-235. So that isotope of uranium is being refined to increase the amount of uranium-235 that's going to be available for the reaction to occur, whatever reaction that is, and we'll get to that in a minute. But for the sake of the bomb, the idea is if we can refine enough U-235, so the more, or the isotope that's less common, if we can refine that to be more prevalent, and then we can contain it, and then launch a charged neutron toward the nucleus of one of those fissile atoms, then it's going to cause a chain reaction where when that neutron bumps into the fissile atom, that will then turn into U-236, which is unstable, and so it will cause the reaction of nuclear fission. So when that splits, it will release more charged neutrons along with breaking down into two other atom types, but those extra neutrons will go and they will bump into some of the other refined uranium-235 and carrying on that reaction until it no longer continues. So I wanted to reference another site I found too. This is, let me pull this down here, Lumen Candela. And one of the things that I thought was interesting just looking at this is this area right here. Hopefully you can see on my screen what I'm circling. The two different assembly types for when we look at atom bombs. There is this gun type assembly method, which is what we saw in the video, where they're going to launch a neutron that's charged over into the pocket of extra refined U-235. But there's also this implosion assembly idea where this is with plutonium rather than uranium, but the idea with this one is going to be that you have plutonium in the middle, but we're going to compress it down. So we're going to put pressure on it, and so as we put that pressure on it, it's going to cause the reactions because we're pushing that type of charge down in it. So that sounded interesting to me. But the idea here with the reaction is going to be, I found actually a whole description here really just detailing it very well. But let me see if there was a particular thing I wanted to reference here. Let's see. So the uranium atom 235 can split into one of a dozen different ways. So there's a lot of ways that nuclear fission is going to take place, but when it does, it's going to release not only the two new atoms, but it's also going to release the neutrons as we talked about. Here's an example right here of an equation showing that nuclear fission into strontium and xenon. Let's see here, what else do I want to mention from this video? Where are we? There we go. Okay. So, let's see. Yeah, that's enough from that site there. Okay. So one of the other questions from our prompt here is just thinking about what is necessary to achieve this reaction. So in the video, it talked a lot about because there's a significant amount more of U-238, it's more common, it's more stable, it is not going to react the way that U-235 does. So in order for an atomic bomb to work, we are going to need a high amount of U-235, so the one that's less prevalent. So how they refine that is they have almost a filtering process, because U-235 is going to be lighter than U-238, and so with it being lighter, based on the pressure systems they have in those filters, it's able to fit through, I think they call it pores, in the filter, and they will repeat this process many times, because it is very delicate work trying to separate U-238 from U-235 because they're super duper similar. So first, for this reaction to even have a chance of happening at the degree that they would need for an atom bomb, you have to refine it thousands of times. I think he said 4,000 in the video, if I'm correct. But so we have to have U-235. We have to have a beginning charged neutron that we're going to launch at the fissile atoms of the U-235, which will then convert it to U-236, which is a very unstable atom, and so it will naturally go through nuclear fission, and when that happens, it'll release neutrons that will then spread out to the other U-235 atoms that we have contained within a certain area. So again, going back to the diagram that they showed in the video, the bulk, well, 40% of that enriched uranium is going to be right here, and then 60% back here, but they're going to launch that neutron over here, and this is what's going to start that reaction that's going to lead to the explosive potential that we see. So that's all I have for this one. If you have any questions, let me know. Thank you for your time.